So in this lesson, we're going to look at the relationship between radicals and rational exponents, and we're going to use that information to simplify radicals and to rewrite expressions that have rational exponents to radicals. So we're going to go from radicals to rational exponents and from rational exponents to radicals. So there is a relationship. Before we look at that relationship, let's review a couple of things. So we know this. We know that the square root of 25 is 5. Okay, that we know because 5 times itself is 25. Okay, we also know this. So if the square root of 25 is 5, then we also know that the square root of 25 raised to the third power, and remember to determine, to evaluate what this is, we need to first of all figure out what the square root of 25 is, and the square root of 25 is 5, but remember that base is being raised to the exponent 3, so it's being raised to the third power, and then 5 to the third power means 5 times 5 times 5, which is 125. All right, so let's look at this one. Suppose I asked you what's the cube root of 8. Well, we all know that the cube root of 8 is 2, because 2 times 2 times 2 is a radicand 8. And then what if I had this, the cube root of 8 to the 5th power? So the cube root of 8 to the 5th power, first of all, the cube root of 8 is 2, but that's being raised to the 5th power. And remember, 2 raised to the 5th power means 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So that's equal to 32. All right, so that was a review that we're going to need in a few minutes. We're going to go back to this in a few minutes. But what if I wanted to know this? What if I wanted to know, find 8 to the 1/3 power? All right, so notice that in this case, my exponent is a rational number. It's written as a rational number, 1/3. Over here, if I had this, see this right here, that's 2 to the 5th. Now my exponent, 5 is still considered a rational number, except we think of 5 as a whole number, an integer. But this right here is not an integer, that's not a whole number, that's considered a rational number. So my exponent here is a rational exponent, so hence this idea right here, rational exponents. So what you want to do to determine what this is to rewrite this expression here, going from rational exponents to a radical. So that's what we're going to learn. We're going to learn how to go from this idea to something in radical form that looks something like this. Okay? So square root of 25, the cube root of 8, this idea right here. Okay, so let's talk about it in this sense. All right, so you got to make sure you understand every little part I'm doing here before you can understand how to rewrite this as a radical. So this part of the lesson is going to be called this, understanding what a number, a non-zero number, a raised to the 1 over n power means. So it's kind of like this. So my base here is 8, and my exponent is 1 divided by n, so here it's 1 divided by 3. So this right here looks like this. So we're going to discuss what this right here means. Okay? All right, so let's suppose that x is equal to 4 to the 1/2 power. Okay? And then I'm going to go ahead and rewrite this. Now remember, one of the things that you've learned multiple times, and you've done multiple times, was this. What you do to one side, you have to do to the other side. So if I square the left-hand side, then I have to square the right-hand side. So what I do to one side, I do to the other. And then we also learned this in a previous course. So we learned something called the power rule for exponents. And so in the previous course, the power rule for exponents said something like this. If I have let's say 3 to the 5th power, and all that's being raised to the, let's say, 4th power, then I can simplify this by doing this. When you have a power raised to power, you multiply those powers. So 5 times 4 is 20. So this would be 3 to the 20th power. You also looked at it in terms of this. If I have x to the 6th power, and that's being raised, let's say, to the 4th power, then that will be x to the, and then 6 times 4 is 24. Now remember, it kind of makes sense if you remember from last semester that what this means right here, this outer exponent, the outer exponent 4, that means you take x to the 6th and you multiply it by itself 4 times. That's what that means. But remember, you also learned the rule that when you multiply like bases, you add exponents. So 6 plus 6 plus 6 plus 6 is at 24. So that's x to the 24th. So that's why this power rule applies, because you also learned this, and then you learned the power rule. So this right here is called the product rule for exponents. Okay, now, so that was a quick review as well from a previous course. So right here then, if see right here where I have a power raised to power, I'm going to go ahead and multiply those powers. So remember, 1/2 times 2, 1/2 times 2 is just 1. So this right here, I'm going to go ahead and rewrite this. So this is x squared equal, and then this right here, that's just 4. 1/2 times 2 is 1, so that's 4 to the 1st, or just 4. Okay, now, I want to get x by itself. So one way to get x by itself, see right now I'm squaring. The opposite of squaring is to take the square root. Now I'm just going to worry about the positive square root here. I'm not going to worry about a negative square root, because if you think about it, a positive 2 times itself is 4, and a negative 2 times itself is also 4. But I'm just going to deal with the positive square root. So I'm going to go ahead and rewrite this over. I'm going to take the square root of both sides. Okay, just positive square root. And then remember, the square and the square root undo each other, so they undo each other. So they're inverses of each other. You're going to learn about inverses in another course. But here I'm just left with x, and the square root of 4 we know is 2. So this right here, okay, so this right here, see this, I'm going to go ahead and compare these two. I'm going to go ahead and do this. That'll be the square root of 4, which we know is 2. Let's write it like this first. So I'm going to go ahead and compare this x right here with this x right here. So we know this. So this becomes x equal 4 to the 1/2. So x is 4 to 1/2. But x is also the square root of 4. So that means that these two expressions are equal. They're equivalent. So remember, the idea was to go from a exponent, from a rational exponent to a radical. And so notice I did go from a rational exponent to a radical. Okay? All right, now let's look at another one, and we're going to come back to this and discuss this. So let's suppose we wanted to look at this. Let's go back to 8 to the 1/3. Let's do the same thing. 8 to the 1/3. So let's find, well, let's say this. Let's suppose that x equals 8 to the 1/3. All right, so just like I did here when I had this, see, the whole idea was to get this to be a 1. So this is 1/2. To get that right here to be a 1, I had to square both sides, because this denominator is a 2. So to get a product of 1, I had to multiply by 2. So here, this is a 3. So to get this product, when I raise both sides to a power, just like I did previously, when I raise both sides to a power, I'm going to raise it to the 3rd power, because it's the only way I can get this exponent right here to be a 1. Okay, so that's important in this progression. So I'd raise both sides to the 3rd power because my denominator is 3, and so I get x cubed equals, and remember, 1/3 times 3 is 1. So that's equal to 8. Now I got to get x by itself. One way to get x by itself is to take the cube root of both sides. So So the cube root of both sides. So I'll go ahead and rewrite this over. So I get the cube root, and so the cube and the cube root undo each other. They're inverses of each other. So you're left with just x. And so I get x equals the cube root of 8. So this right here, so x equal 8 to the 1/3, which also equals the cube root of 8. Okay? So this is what we know now. Okay, so let's look at what we know. We know this. And let's look at this pattern. So we know that 4 to the 1/2 is the square root of 4. We also know that 8 to the 1/3 is equal to the cube root of 8. So the question becomes this: what if I wanted you to tell me what was, let's say, 6 to the 1/4? All right. Well, look at this pattern. So this 2 here, this denominator 2, and this denominator 3. What do you notice when you rewrite this rational exponent into radical form? This 2 becomes what part of the radical? So if you stated that the 2 becomes the index, that's correct. So you see this 2 right here? That's square root. So remember this index, if there's no number there, it's understood to be a 2, square root. So index is 2. Here my denominator is 3, that's your index. So here, that would become the 4th root of 6. That's what that becomes. So let's go back to this right here, a to the 1 over n. So you need to know this. You need to know that a to the 1 divided by n can be written. Now remember, the numerator has to be a 1 for our discussion right here. So a to the 1 divided by n is the nth root of a. That's what that is. So a to the 1 divided by n is the nth root of a. So if you had this, let's say you had 27 to the 1/3 power. 27 to the 1/3 power. So if you want to find 27 to 1/3 power, well, that's going to equal, using what we just learned, the denominator 3 of this rational exponent becomes your index. So it'll be the cube root of 27, and then the cube root of 27 is just 3. Okay? All right. So if you had, let's say, 64, let's say you had the 64 raised to the 1/4 power. Make sure, let's say 16. I think we did 16 already. No, we didn't. Let's just say this, 16 to the 1/4 power. So remember, that means the 4th root, the index is 4 because my denominator is 4. The 4th root of 16, and then the 4th root of 16 should be 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it'd be 2. Okay? All right, now, so that takes care of that part. But what if I had this? Let's say we want to find 8 to the, let's say, 4/3 instead. 8 to the 4/3. So we know this. We know that 8 to the 1/3 means the cube root of 8, which is 2. But what is 8 to the 4/3? How do I deal with this rational exponent if my numerator is not a 1? In this case, my numerator is a 4. All right, so what we're going to do now is try and understanding what a to the m divided by n is. That's what we're going to try and understand now. How do I rewrite a to the m divided by n in radical form? That's a question. Okay, so let's look at this then. Suppose I had this. All right, suppose I had, suppose I told you that x equals 9 to the 1/2, actually, let's do this. Let's go back and do this. We know this. We know that 9 to the 1/2 is the square root of 9, which is 3. Okay, so let's talk about what about 9 to the 3/2. Just like we were going to try and figure out what about 8 to the 4/3. Okay, so let's look at this progression. Okay, so we know this. All right, so look at this carefully. So I'm going to look at this right here. 9 to the 3/2, 9 to the 3/2 is equal to, now remember a while ago we looked at those properties. So look at these properties right here. The power rule and the product rule. So we're going to use this idea right here. All right, so we know this. We know that 9 to the 3/2 means the same thing as this. 9 to the 1/2 raised to the 3rd power. So you got to understand that this exponent is the same thing as saying this, because 1/2 times 3 is 3/2. Okay, so that's important to understand that all I did was I rewrote this like this. So it does make sense that these two are equivalent. They're the same thing, because 1/2 times 3, a power raised to power, you multiply. 1/2 times 3 is 3/2. Now look at this right here. This 9 to the 1/2. My numerator is 1, so I know how to rewrite this. That becomes the square root of 9, 9 to the 1/2 is the square root of 9, all raised to the 3rd power. And so I want you to note this. 9. So now we know this. We know this. We know that 9 to the 3/2 is this. Look at what I have. Now let's compare the denominator. So remember, the denominator is your index. Now what do you notice about the numerator? Your numerator is that outer exponent. Your denominator is your index. Your numerator is that outer exponent. And once you rewrite this as a radical, then it's easy to determine. The square root of 9, is 3, and 3 raised to the 3rd power is 27. Okay, so now let's go back. So now we know this. Well, let's go back and talk about 8 to the 4/3. 8 to the 4/3. So 8 to the 4/3, we're going to do the same progression. 8 to the 4/3. We know is this. It's 8 to the 1/3 raised to the 4th power. Make sure you understand it's the same thing we just did. So 1/3 times 4 is 4/3. But we already know what this is. This right here is the cube root of 8. 8 to the 1/3 is the cube root of 8. But that's being raised to the 4th power. So remember, this rational exponent, in which case the numerator is no longer 1, I can write as the cube root of 8, all raised, and then the numerator becomes the outer exponent. And so once you rewrite it like this, once you rewrite it as a radical, you can now go ahead and simplify this. The cube root of 8 is 2, and 2 to the 4th power is 16. Okay? So now we are trying to understand what a to the m divided by n is. So this rational exponent I can write as, and let's go ahead and do that here. So a, we now know this. We now know this. A to the m divided by n will be, all right, so remember the denominator is your index, so it'll be the nth root of a, and then all that's being raised to the m power. All that's being raised to the m power. Okay? All right. So now let's look at this. So let's do these examples. All right. Example 1. Okay, so we're going to simplify, evaluate. Okay, number 1. 4 to the 3/2 power. Okay, so 4 to the 3 has power. You're going to rewrite. Remember, you got to know these two rules. You got to know that a to the 1 divided by n is the nth root of a. We also know that a to the m divided by n is the nth root of a to the m power. All right, so all you know is that your denominator is your index and your numerator is that outer exponent. So this becomes the square root. Your denominator is 2, that becomes your index of the base, which is 4, all raised to the third power. So the first thing you have to do is rewrite as a radical. That's the first thing you have to do. Once you write as a radical, then it's easy to evaluate. The square root of 4 is 2. Square root of 4 is 2, so that's I get the base. And then 2 to the third power is 8. Okay, number 2. The answer is 8. So in the blank, if you have 4 to the 3 halves, you would say that the answer is 8. Number 2, suppose I had 100 to the 5 halves. 100 to the 5 halves. Well, that becomes, so you see this rational exponent, you want to change it to a radical. So it becomes the square root, because my index is 2, of 100, and all that's being raised to the 5th power. Well, the square root of 100 is 10, and 10 to the 5th is 1 and 5 zeros. 2, 3, 4, 5. So it's 100,000. Okay, number 3. Suppose I had, let's look at 16 to the 3/4. 16 to the 3/4. Okay, well, 16 to 3/4 becomes, remember, your denominator is your index, so it'll be the fourth root of 16, all that's being raised to the third power. All right, now once I write as a radical, the fourth root of 16 is 2, and 2 cubed is 8. So 16 to the 3/4 is just 8. Number 4, what if I had this? Negative 16 to the 3/4. Negative 16 to 3/4. Now you got to be careful with this. You got to remember this fact. So remember this. If I have, there's a difference between, let's say, negative 5 squared and negative 5 in parentheses squared. So negative 5 squared versus negative 5 in parentheses squared. So here, the one I'm pointing to now, what's being squared is negative 5. So negative 5 times itself is a positive 25. In a previous course, you learned that if there's no parentheses there, then the only thing being squared is this 5 right here. So if you cover this negative symbol, then 5 squared is 25. But you're taking the opposite of that, so that's a negative 25. So again, if there's no parentheses there, the 5 is the base that's being squared, not negative 5. So over here, what's being raised to 3/4 power? It is not negative 16, it is just 16. So what you need to do is cover up this negative symbol and then rewrite this as a radical. So that becomes, this right here becomes the fourth root of 16, and that's being raised to the third power. And whatever that is, then that's going to be negative. Okay, so the fourth root of 16 we found to be 2. So the fourth root of 16 is 2. And then that's 2 cubed. This right here is 2 cubed. But remember, there's a negative out there. So 2 cubed, remember, is 8. So that becomes a negative 8. So negative 16 to a 3/4 power is a negative 8. Okay? Now let's look at this one. Suppose I had, number 5, suppose I had 8, let's see, 8 divided by 27. 8 divided by 27, and all that's being raised to the 5/3 power. 8 divided by 27, all that's being raised to the to the 5/3 power. Okay, so first of all, we're going to change this to a radical. So I'm going to change it to the radical. Remember, your denominator is your index, and your numerator is that outside power, that outside exponent. So this time it's a fraction, but that's okay. We can deal with that. So that's the cube root, your denominator is your index, of this base, 8 divided by 27, and all that's being raised to the 5th power. All right, so let's go ahead. So remember, the first thing you have to do was rewrite as a radical. So then you're going to go ahead and simplify this. The cube root of 8 is 2. The cube root of 27 is 3. And then you're raising that to the 5th power. So this part here becomes 2/3. And then we just got to figure out what 2/3 to the 5th power is. Well, remember, 2/3 to the 5th power means 2/3 times itself 5 times. So basically, from last semester, you just learned that you just take the numerator, raise it to the 5th power, and then take the denominator, raise it to the 5th power. So 2 to the 5th means 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So that's the numerator. The denominator, 3 to the 5th, means 3 times 3 times 3 times 3 times 3. So you may need to use a calculator here. 3 times 3 is 9. 9 times this 3 is 27. 27 times 3 is going to be 81, and then 81 times 3, I'm going to go ahead and use a calculator for these, is 243. So this whole thing here is 243. So that's your fraction. So 8/27 raised to the 5/3 power equals 32 divided by 243. Okay, let's look at one more, number 6. Suppose we had this. Suppose we had 16 divided by 81, all raised to the 3/4 power. So notice I have a rational exponent. So you want to change this to a radical. All right, so when I change this to radical, I'm going to get, remember your denominator is your index, so it'll be the 4th root of 16 divided by 81, all raised to the outer exponent, and your numerator is that outside exponent. And so what we do now is simplify this part. So I go off to the side if you need to, and simplify what the 4th root of 16 over 81 is. So the 4th root of 16 divided by the 4th root of 81. So the 4th root of 16, so what number times itself 4 times is 16? Well, that's 2. And then what number times itself 4 times is 81? Well, that's 3, because remember, think. Let's do this again. 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So this right here becomes 2/3. So that's this right here. So this becomes 2/3 raised to the 3rd power. And so 2/3 raised to the 3rd power, remember that means 2/3 times 2/3 times 2/3. And so 2 times 2 times 2 is 2 times 2 is 4, 4 times 2 is 8, and then 3 times 3 is 9, 9 times 3 is 27. So it becomes 8 divided by 27. So 16 divided by 81, all raised to the 3/4 power, becomes 8 divided by 27. All right, so what we learned here was this. So you got to know these rules, so to speak. If you have a to the 1 divided by n, that's an n. So whenever you have rational exponents, you want to change it to a radical. And as a radical, this becomes, now if the numerator is 1, it's very easy. It's just the nth root of a. Because the numerator is 1, so all that's being raised to the 1st power. And we know that a to the m divided by n is the nth root, again, the denominator is your index, of a, and all that's being raised to the numerator, so all that's being raised to the m power. So now you know how to deal with rational exponents. So to simplify expressions that involve rational exponents, you first of all are going to change it to a radical, and then you go from there. Okay?